Welcome to this lesson on the Docker ecosystem overview. Today, we're going to explore the various components of the Docker ecosystem and how they work together to streamline containerization and deployment efficiency. We'll start by introducing the key components of the Docker ecosystem, including Docker Hub, Docker Swarm, and Docker Compose. By the end of this lesson, you'll have a clear understanding of how these tools can be used to improve deployment efficiency and simplify containerization. In this lesson, we have 4 main learning objectives. First, you'll understand the key components of the Docker ecosystem. Second, you'll learn how to use Docker Hub, Docker Swarm, and Docker Compose to streamline containerization and deployment. Third, you'll apply best practices for containerization and deployment efficiency. Finally, you'll learn how to troubleshoot common issues with Docker ecosystem components. Now let's take a closer look at the Docker ecosystem. The Docker ecosystem is a set of tools that work together to simplify containerization and deployment. Docker Hub is a registry of Docker images, which provides a central location for storing and sharing Docker images. Docker Swarm is a container orchestration tool that allows you to manage multiple containers as a single unit. Docker Compose is a tool for defining and running multi-container Docker applications. So, what are the benefits of using the Docker ecosystem? First, it improves deployment efficiency by allowing you to define and run multi-container applications with ease. Second, it simplifies containerization by providing a standardized way of packaging and deploying applications. Third, it increases scalability and reliability by allowing you to manage multiple containers as a single unit. Finally, it enables faster application development and deployment by providing a platform for rapid prototyping and testing. Now let's take a closer look at Docker Hub. Docker Hub is a registry of Docker images that provides a central location for storing and sharing Docker images. It supports both public and private repositories, which allows you to control access to your images. Docker Hub also integrates with the Docker CLI and other tools, making it easy to push and pull images from the registry. Next, let's explore Docker Swarm. Docker Swarm is a container orchestration tool that manages multiple containers as a single unit. It provides features like service discovery and load balancing, which allows you to scale your applications horizontally. Docker Swarm also supports rolling updates and self-healing, which enables you to update your applications without downtime. Finally, let's look at Docker Compose. Docker Compose is a tool for defining and running multi-container Docker applications. It provides a simple way to define and manage complex applications and supports features like service discovery and volume mounting. Docker Compose also integrates with Docker Hub and other tools, making it easy to push and pull images from the registry. Now, let's take a look at an example of using Docker Compose to define a simple web application. In this example, we're using the Docker Compose YAML file to define 2 services, Web and DB. The web service uses the Nginx image and maps port 80 on the host machine to port 80 in the container. The DB service uses the Postgres image and sets environment variables for the database. We can run the application using the Docker Compose up command and access it at http localhost 80. Next, let's take a look at an example of using Docker Swarm to create a cluster and deploy a service. In this example, we're using the Docker Swarm init command to create a new Docker Swarm cluster. We're then joining a node to the cluster using the Docker Swarm join command. Finally, we're deploying a service to the cluster using the Docker service create command. The service is deployed and running on the cluster, and we can verify this using the Docker service ls command. Now that we've explored the Docker ecosystem, let's talk about some practical applications. We can use Docker Hub to store and share Docker images, which provides a central location for our images and makes it easy to collaborate with others. We can use Docker Swarm to manage and orchestrate containers, which provides features like service discovery and load balancing. We can use Docker Compose to define and run multi-container applications, which provides a simple way to define and manage complex applications. Finally, we can use the Docker ecosystem to improve deployment efficiency and scalability, which enables us to deploy applications quickly and reliably. As we continue to work with the Docker ecosystem, it's essential to follow best practices and use advanced patterns to get the most out of our containers. We can use Docker volumes to persist data across container restarts, which ensures that our data is safe and available. We can use Docker networks to enable communication between containers, which allows our containers to talk to each other. We can use Docker secrets to manage sensitive data, which keeps our data secure. Finally, we can use Docker health checks to monitor container health, which ensures that our containers are running correctly and performing well. As we work with the Docker ecosystem, it's essential to be aware of common mistakes and debugging tips. One common mistake is using the latest tag in Docker images, which can lead to unpredictable behavior. Instead, we should use specific versions of Docker images to ensure consistency. We should also monitor container logs and metrics to detect issues early. Finally, we can use Docker Inspect to debug containers and understand what's happening inside our containers. To get the most out of the Docker ecosystem, it's essential to follow best practices and optimize our containers. We should use Docker images with minimal dependencies to reduce the attack surface and improve performance. We should optimize Docker images for size and performance to reduce storage and network usage. We should use Docker volumes and networks efficiently to reduce overhead and improve communication. Finally, we should monitor and analyze Docker container performance to identify bottlenecks and optimize our containers for better performance. The Docker ecosystem has numerous real-world applications and case studies. We can use the Docker ecosystem in web development and deployment to improve efficiency and scalability. We can use the Docker ecosystem in microservices architecture to manage and orchestrate multiple services. We can use the Docker ecosystem in DevOps and continuous integration to automate testing and deployment. Finally, we can use the Docker ecosystem in big data and analytics to process and analyze large datasets. Security is a critical aspect of the Docker ecosystem. We can use Docker security features to protect our containers from unauthorized access. We can use Docker secrets to manage sensitive data and keep it secure. We can use Docker networks to isolate our containers and prevent communication between them. Finally, we can use Docker volumes to persist data securely and ensure that our data is safe. Monitoring is essential to ensure the health and performance of our containers. We can use Docker monitoring tools to track container performance and identify issues. We can use Docker logs to debug containers and understand what's happening inside them. We can use Docker metrics to analyze container performance and optimize our containers. Finally, we can use Docker alerts to notify us of container issues and take corrective action. In conclusion, we've explored the Docker ecosystem and its various components, including Docker Hub, Docker Swarm, and Docker Compose. We've learned how to use these tools to streamline containerization and deployment efficiency. As next steps, we recommend exploring the Docker ecosystem further and learning more about its features and capabilities. We also provide additional resources for further learning and support. Finally, we encourage you to start using the Docker ecosystem in your own projects and applications, and to share your experiences and feedback with the community.